Well, it's a matching type question, question 16, and it says liquid of total mass m equal to pi r square h rho g, r is radius of base, rho density of liquid is put into 4 different containers of same base radius r as shown in entries in column 1. Match the entries in column 1 with entries in column 2. Ignore atmospheric pressure. Okay. So, entry A on column 1 is a cylinder. Now, cylinder has same radius throughout. Okay. So, the total volume of liquid is pi r square h rho g. Well, it's very clear that it should be taken as pi r square h rho. It's a typographical error, so we can just ignore this. And that being the case, the height of liquid in this case is h only, right? Because pi r square h rho is the mass, so that means the volume itself is pi r square h. So this height of the liquid in first case is h. Rho is the density of the liquid, and atmospheric pressure is to be neglected. So pressure at base will be rho g h. So if this pressure, atmospheric pressure, is to be neglected, pressure at the base will be rho g h. So A matches with P and it will not match with QR. Net force due to side wall on liquid is downward. In this case, net force due to side wall on liquid will be in fact 0 because it's horizontal and it will cancel. So A matches with P, it does not match with either S or T also. Let's look at B now. So if we see B, now this height is clearly greater than this height is h dash is clearly greater than h because it's a tapering vessel and the radius at the base is r. So the area of cross section is decreasing as we are going up. So since the volume is still pi r square h, so its height is greater than h, which means pressure at the bottom will be greater than rho g h. Pressure at the bottom is rho g h dash, which is greater than rho g h. So that means for B, Q is correct. And if we look at force due to sidewall on liquid, we can see that everywhere the sidewall is applying force perpendicular to itself, so everywhere it has a vertically downward component. So the net component vertically downward will be there. So that means S also is matching. Net force due to sidewall on liquid is downward is correct. So B will match with both Q and S. And that's all for B. If you look at C, now this height, if I call it h dash is clearly h because it's tapering, its radius is increasing as we go upward. So volume being same, this height will be less than h, and so pressure at the bottom, at the base, will be less than rho g h. So that means on column 2, pressure at base is less than rho g h will be correct. That means for C, R will match. And everywhere the force by the side wall is directed perpendicular to itself. So it has a vertically upward component. While horizontal components will cancel, vertically upward components, they will all add up because they are all in the same direction. So net force due to sidewall on liquid is upward is also correct for C. So that means for C, R and T both are correct. Let's now look at D. So here radius is R and then it is going down, it's a minimum and then it's increasing. And well, if you assume that situation is symmetric, then we can very clearly say that at this point, first of all, we can see that the average radius will be less than r. So this means that h dash is greater than h because the volume is fixed, and if overall radius or overall area of cross section is less than pi r square, so equating the volume h dash will be greater than h. So pressure at bottom is greater than rho g h. So that means Q will match for D. So D, Q matches. And if we look at force by side wall on the liquid, so on this portion it is upward, but on this portion it is downward, right? But pressure we also know is greater on the lower side. So overall, looking at the figure, we can say that the force by sidewall on the liquid will be in the vertically downward direction. So that means it will match with S. So that means for question 16, this is our matrix match. Let's go to the next question now. Question 17 says, a progressive sound wave is traveling in positive x direction. Displacement of medium particle at t equal to 0 is plotted with position of medium particle. Attributes of point mentioned in column 1 is matched with column 2. And this is the graph. This is the graph between displacement of the medium particles, which is plotted on the y-axis, with position, which is plotted on the x-axis. And this is the situation at t equal to 0. Now in column 1 we have point A, B, C and D. A, B, C and D are here in the graph. And in column 2 we have entries like velocity of medium particle is 0, speed of medium particle is maximum, pressure is minimum, pressure change is 0 and pressure is maximum. Well, needless to mention, it's a question from the topic waves. In fact, that too from sound wave. Now the key concepts here are, we are concerned with particle velocity and pressure. In fact, these two are the key items to be considered here. Now, wave is traveling in positive x direction. So, if that is the case, then expression for particle velocity happens to be equal to minus speed of wave, let's call it c, which is the speed of wave, into the slope at that point, which is del y by del x. This is for particle velocity, and as far as pressure variation goes, we have expression delta P is equal to minus B, the bulk modulus, into del Y by del X. These are the key ideas that need to be used. The first one is about particle velocity. If the wave is traveling in the positive x direction, remember quantity C is positive. And similarly, for change in pressure from the normal pressure, delta P is minus B into del Y by del X. Now let's look at A. At A, we know that del Y by del X is 0. The slope is simply 0 here. So the particle velocity at A is 0. So that means for A, velocity of medium particle is 0, will suit exactly. Whereas delta P is going to be 0. That means pressure change is 0. So we have for A, P as well as pressure change is 0, S. These two will match. For B, point B, well, among all the points, the slope has maximum magnitude at points, these points, right? B and D. So, and magnitude wise slope at B and D are equal. Of course, slope at B is negative and slope at D is positive. So, as far as speed goes, speed will be maximum at point, in fact, at points B and D both. So for B, we can clearly say that speed of medium particle is maximum. So B matches with Q, and change in pressure will be maximum, and in fact it will be on the positive side because delta Y by delta X is negative at B. So change in pressure is maximum, which means pressure also is maximum, right? So pressure is maximum will also be satisfied for B. So Q and T match with B. Well, at C again slope is 0, which means the speed is 0 and pressure is, in fact, pressure change is 0. So that means for C we can again write that C will match with P and S like A. And for D, well, slope at D is positive. That means delta P is negative, and in terms of magnitude it is high. So this will be a point of minimum pressure. And in terms of speed, it is maximum speed. So D will match with Q and R, right? Q because the speed will be maximum as per the first expression. And at this point, delta P is negative and has maximum magnitude. So the pressure is minimum. So this is our matrix match for question 17. Let's go to the next question now.